C6.2 Electrolysis of solutions. I want to recap initially. Let's look at the setup here, the equipment that's used, and how this works, and look at how we write some equations to explain what happens. So first thing I would like you to do is consider three things in this diagram. We've got the molten ionic substance here, so it's now a liquid. We have two electrodes. They both have a name. Can you remember what they are? Can you label them? Have a go at that. Pause the video. Okay. We have molten ionic substance here, which is known as the electrolyte. Doesn't matter what that ionic substance is, when it's molten, it's going to be the electrolyte. That will conduct the electricity. We have two electrodes. The positive electrode is known as the anode, and the negative electrode is known as the cathode. Okay, the ode part is the electrode, and cath denotes whether it's positive or negative. Okay, let's consider what happens in this scenario. So when we switch the power pack or the battery on, it pumps electrons around the circuit. Now these electrodes can be made out of carbon or graphite. The atoms of the graphite have delocalized electrons, and those delocalized electrons are free to move. So when we switch the power pack on, the electrons get pumped around the circuit and they're deposited on this side. Not all of them, but some of them. It makes this electrode negative, and that electrode, which has lost some of its electrons, is now positive. Okay? So what happens? Sodium, being positively charged, is attracted to the opposite charge electrode. Okay, so the positively charged ions are attracted to the negative electrode, or the cathode. So they will move over here and they will migrate and come into contact with that electrode. Okay, now when they get there, they pick up an electron, one each. Okay, and we can write that in an equation. So each sodium ion picks up one electron, and it forms sodium solid. So it's solid sodium metal. Okay. On the other electrode, two chlorine ions, they give away their extra electron. They have an extra one. They give it away here. So they put electrons on this side and they form chlorine gas, Cl2 gas, plus 2 electrons. So they give away their extra electrons and they form chlorine gas. And that gas is then given off at the electrode. Okay? So what you will see here is bubbles of chlorine gas escaping, and on this side you will see a deposit of sodium, or sodium coating that electrode. So you'll be expected to not necessarily write the simple equation at foundation. Certainly at higher you'll be expected to do the equations, but you will need to understand how this works. So the positive ions take electrons off on the negative side, and the negative ions give their extra electron away and put it onto this electrode. Okay. Now let's consider what happens if instead of melting our sodium chloride, we dissolve it in water. So when we dissolve it in water, remember, water has the formula H2O, yeah? I'm going to write it like this. So 2 hydrogens, 1 oxygen. And this splits into ions. So I've written them here, H plus ion and an OH minus ion. So when we dissolve sodium chloride in water, there are now 4 ions, 2 negative and 2 positive. Okay? Now exactly the same sort of process can take place. We switch on the power pack or the battery. Some of those delocalized electrons in the graphite are pushed around to this side, making this side negative, and this side that's lost electrons is now positive. The negative ions are attracted to the positive electrode, and the positive ions are attracted to the negative electrode. However, there is a different rule that we need to apply here, and it's this. The least reactive positive ion is always given off first, except not there. Sorry, that one. So hydrogen is going to be given off at the negative electrode, and sodium remains as sodium ions. On this side, with the negative ions, the rule is if you have a halogen, chlorine, fluorine, bromine, iodine, if you have any of those, they will always be given off first. If you don't have a halogen, then oxygen gas will be given off by this. Okay, so the rule is if you've got a halogen, that will always be given off first. If there is no halogen, oxygen is given off. So in this case, because we've got a halogen, that will be given off at the positive electrode, and we get chlorine gas coming off. Okay, so some simple rules here that you need to follow. If we look at the equations here, let's look at hydrogen first. If we take 2 hydrogen ions here, they go across, they pick up electrons from here, and they form hydrogen gas. So 2 hydrogen ions go across here, they pick up electrons, they form hydrogen gas, and they escape. If we look at the chlorine, again, it's the same as last time. So 2 chlorine ions will give away their electrons, and they will form chlorine gas. And there we have the half equations. So high students need to be able to write these. Foundation students, a word equation will be sufficient, but you do need to understand which ions will be moving across the electrodes first, and the difference between the solution and the molten state, and why they're different. Okay, so you'll get a different outcome if you dissolve the salt than if you melt it. In this case, it's a very useful setup where we can produce hydrogen gas and chlorine gas, which are both useful products, and we're left with sodium hydroxide, which is an alkali, which can be used for things like soap. So all of this is very useful. So the electrolysis of sodium chloride, which is also known as brine, the electrolysis of brine is a useful industrial process that you will be referred to in the exams. So you need to be clear on this specific case.